Hi guys, seems like you are ready for the next step in solving systems, which would be solving systems by substitution. That's the third and final method. And when you would use substitution is when one of the two equations that you're looking at is set up so that, or written so that y equals something or x equals something. An example of that would be like, well, an example and a non-example would be like this is kind of what we were looking at when we were solving by elimination, where you have x and y both on the same side of the equal sign. In something like this, maybe one equation would have x and y together on one side of the equal sign, but the other would have either x over here by itself or y over here by itself. So this would be a time when you would want to use the substitution method instead of the elimination method. So there are some steps. The first step is to take whatever that equation was, what does x equal or what does y equal, and substitute it, thus the name, substitution, back into the other equation wherever the x or the y is. So for example, if you had 3x plus 2y equals 12 and 5x minus 7 equals y, you know what y equals. Y equals this expression here, 5x minus 7. So you can put it in where the y is. You're substituting this expression in place of y. So your old equations were these two. Your new equation would look like this. You took the 3x, left it alone, plus, left it alone, 2 times y up here becomes 2 times whatever y equaled according to your other equation. You put the 5x plus 7 right in the equation, and it equals 12 like it did originally. So how do you solve that? First, you would solve for the variable. In this case, we're solving for x. We don't have a y anymore, if you notice. We got rid of it. So we're going to walk through how to solve for x. First, you would use the distributive property to distribute the 2 to the 5x and the negative 7. 2 times 5x is 10x. 2 times negative 7 is negative 14. Then you combine like terms, combine the 3x and the 10x, and you get 13x. Bring the minus 14 down, bring the equals 12 down. Then you would solve, like we've been practicing algebraically, solve for x by adding 14 to both sides, and then dividing both sides by 13, and you get x equals 2. So I'm sure you remember that solving a solution or finding a solution set for a system is like you need a coordinate pair. So we have the x value. Now we have to figure out what the y value is. And to do that, you substitute your known quantity. So in this case, it was x. That was what we solved for. Substitute it back into one of your original equations and then solve for the other variable. I decided to choose this equation to put x into because it's fewer steps. I can just solve this side if I have a number for x and I'll know what y is. If I put x in here, it's going to take a little more work to solve for y. So as you know, I'm all about being efficient, and that makes me pick this equation. So I take what was x, it was 2. We found that out on the other page. I put that in place of x in the equation. So now instead of 5 times x, it's 5 times 2. Minus 7 equals y. And I just solve that and find out that y equals 3. So my solution set is 2, 3. I'm going to put another example up on the screen here. I'm not going to talk through it. I'm just going to leave it for you to look at. You can pause if you need to take some time to look through. And then hopefully that will be enough explanation for you to try a couple of these on your own.